Okay, let us deal with a more complex centroid shape. Say we have a centroid, say we have a object like this. So it's what, about 30, 54 millimeters long. Say I cut out a bit of sheet steel and I want to find out where the centre of area is on that. How would I do that? And we do have an approach. The general approach to solving this is the centroid. We're going to work out the centroid in the X dimension, and then we're going to work out the centroid in the Y dimension. So what we can do is we can break this up into smaller areas. So I can work out, this is area 1, this is area 2, this is area 3, and if I know where the centroid is of each section, 1, 2, 3, I can then use a formula. Centroid X is equal to the sum of area times distance X all over distance A, or all over the area. So how does this actually, and then we did the same thing in the Y dimension, of course. Cy equals sum of area distance Y for the centroid over the sum of the areas. So how do we actually apply that in reality? I mean, it's got a bit of math in there, more math than most people want. So actually we can break this down into a series of steps. So step 1, define a 0, 0 point. This is the point where we're going to be measuring all of the distances from, because we need to know how far distances of the centroids each individual centroid is. So we usually define that point down there, 0, 0. So we usually define the bottom left-hand corner as 0, 0. And the reason for doing this is, as we go across, all of these numbers are positive, all these numbers are positive. Don't have to worry about negative numbers. There is one case we have to worry about negative, but we'll deal with that later. 2, we break the shape up. The shape into simpler shapes. So this is fine. If we can break that up into rectangles, triangles and circles, yep, we can do this quite easily, believe it or not. Okay, and then 3, what we're going to do is we're going to make up a table. And this table is going to have quite a bit of information on it. So that's what we do with this table. Down here we're going to have the number of the shape. And then, so we've got 1, 2, 3 shapes. We've broken it up into shapes. 1, 2, 3 shapes. We're going to work out the area, to find the area of each shape. That's cool. So we end up with the column for area. Find the distance from 0, 0 to the centroid for each shape. So what we can do here is distance 1 is going to be in the X dimension. Distance X is going to be from there to there. That's the centroid of shape 1. The centroid of shape 2 is here, so we'd add on that, then that. Centroid of shape 3 is there, so we go from there plus there to there. And then we'll do the same thing going up. So we're going to need a distance X. Then we multiply A by times dx. So we've got A dx over here. And then we repeat for y. So we've got dy, and we do a dy, like that. Then for sum up area, ADX and ADY. And then finally use the equations to find the centroid in X and the centroid in Y. And this is the equations we just used up here. So Cx equals sum of ADX. So it equals this one divided by sum of A, which is all of these ones added up. So we'll do an example of this in a second. See y equals sum of A dy. So we add all of this one up. So this is going to be the sum. So this is sum of A, sum of ADX, sum of ADY. And we're going to divide that by the sum of area, divided by that. And that gives you the centroids. And then 6, draw the centroid on one figure. So what we'd literally do is we go along here. If we figured out this was 25, we go 25. If this is 12, we go up there where they meet. That's going to be the centroid. So we'll do an example of this in a second. Well, in fact, we'll do this exact same figure in a second. So catch up on the next video.